Hi everyone, welcome back to my channel. So for this video, I thought I'd do something a bit more fun to shake things up because we've been surfacing the whole car, but we are missing the wheels. So I'd like to model this and follow me for this fun process. I'll show you how to do them pretty fast, precise, and almost production accurate. So check this out. To the new ones tuning in, subscribe and turn on the notifications. For the rest of you, thank you for coming back, and let's dig into this. We've got this nice wheel here. It's looking good. Not 100% my taste, but whatever. Let's build these. And we'll need some information. So for the geeky side of things, I've dug up the numbers. So I'll post all these links in the description below. We'll know exactly what rim to build, so meaning width, flange, and this and that, and the ET. For those things, I'll post these online. So we've got here the flange types. We'll rebuild these in some quick curves, and then we'll spin them around and we'll get a nice wheel similar to this. And here's a shout out to MoTrend. They've been nice enough to put this on their website. This is the anatomy of a wheel, so this is what we will be working to. So this is missing the rims here, and it looks a bit, I don't know, boring. So what I want to do is get those surfaced in, and for that we need the following things. I don't want those sections there. We just need the wheels that I've positioned based on those wheel arches. Those will be my reference of where I'm going to build them. So I'll turn off surfaces, and on my wheel layer I'm going to turn off the symmetry, and we will start working with the front one. Now, I mentioned before all those nice resources. I found one more that's relevant to us. So we've got this here. We've got the rim width is actually measured between the flanges on the outside and inside of the wheel. So that's relevant to us. And then here we have front wheel, which is a 9J20 and it's an ET44. Let's pull up those numbers, right? So that means we've got 9 inches between the flanges and 20 inches on the bead seat. Basically, that means we are measuring from here to here the 20 inches and the width from this line to this one. So let's get those numbers into Alias, and then we'll pull up canvas and we'll start working with that. So I'll hide these. Better yet, I'll template them. Just get myself the reference for the face of the wheel, and that's for the front. So it's at 9, right? So that means a line which is 9 inches wide. So we go, so that's the width of our wheel. This, we center the pivot, we move it halfway there. That's cool. And then we will take the radius here. So we've got the center of that wheel, and we'll drop a line in there as well for our reference. That's it. So we have now the center of that. So that will help us with the ET. And we have the width. That's cool. And then what we need is the diameter, which is 20 inches. Let's get that into millimeters. It's 508. So from that point up, and if it was 508, it's 254. That will move into that point. This curve moves up there. And now that we have all that, let's pull up a canvas. So we'll do import canvas. There we go. We've got the bead profiles. Nice one. So we know we've got a J flange, and we know we'll have 11 millimeters here. So let's do a little line here. Outboard, which is 11 mil long. And let's drop a line in that goes vertical. I'll adjust the transparency here on this canvas. Now we can do the work properly. And now we'll just scale this till those lines meet that 11 mil requirement. There we go. That's it. Now the next thing we said, we need to place the width, right? So the width on the J profile is intersection of this line with this other one, and then we do the 5 degrees. So this moves up and up to this point here. There we go. Let's drop a line in there and rotate it in X. This is minus 5 degrees. That's about it. So I brought in here some circles, as you've got here an R measurement there, and you see that we've got here 11 mil going across. And we have these values that we can see in this section here. So we've got a 9.7, then we've got a 9.7 circle. So yeah, in theory we should rebuild that blueprint, but for the sake of precision, let's make it correct to these sizes. So I'll bring in some curves, I'll add some radii to them to make sure that I'm respecting those, and that I'm respecting these sizes there. So watch me do this. So I'll add here a fillet between the two curves. Hopefully I will manage to get that 6.4 in there. And it will be a G1 tangent. Form factor 1. Let's do 2 for the sake of argument, similar to this. So we don't need anymore. Let's give it a nice color and keep on going. Okay. Now we can extend this curve all the way there. And fit curve this one end to end up there, the other one there. Let's do degree 3, 4. That's it. We've got a very small deviation there, so that is okay. And now let's do this. Pull this back. Get this to sit there. And align this curve to that one tangent. There we go. And then we know that this one will align tangent to that one. And then align this to that. So you've got a correct flange there. This is important, and the rest will follow. So we have that width there. Now we can hide this. I'm going to take these curves, turn on the CVs on them, delete the history and group them, and I'll move the pivot there. What I'll do, I'll mirror it and get it across there. This will have the correct width. Actually, to be 100% precise, what we can do is actually extend this curve, this one, to get their theory, and then this group gets its pivot moved there. That we don't need. We know that this curve is symmetric, so that gets mirrored onto the other side. So we go into Edit, Duplicate, Mirror, and it's going to be the ZX plane. And we move it across here, and we have a correct flange setup. Let's look at the pictures that I showed you earlier. So we've got this one and we've got that one, and what we build between them, that's more of an engineering thing, but let's do something nice and clean. So for the sake of argument, that's our profile for our rim. They say it's an ET44, and these guys say that's a positive offset, this is a negative one. It's just, yes, going outward it's positive, going inboard, so towards the engine, if you want to put it that way, that's negative. So we've got a positive 44 on the front, and this is a tolerance between 42 and 46. Let's do that. We've got this here. That means that this curve can be offset towards the outside by 44 millimeters. This curve, we shrink it a little bit. That's it. So we've got the profile, the diameter, and the ET. So that's really good. This allows us to start building the rim. And the important bit is deciding which rim, because this rim here, the one that we see here, is somewhat different to the one on here. So this one and this one. I recommend you decide which one you want to do. I'll stick with that one. And you have to study this in detail because this is a bit more defined and I like it a lot. But what we can see straight off the bat is that this front surface is, let's say, if you continue the surface in the center, it's a little bit more outboard compared to the edge of the rim. So let's get that in there. So we have one line that could go from there to there. So point 1, point 2 is, it's a curved one. So there's a certain roundness to it. So I'll take these 2 points and move them ever so slightly out till that line starts feeling like that. So it's not much, but it's enough. I would say that's okay. Let's extend this a little bit back. So those will be our building blocks. Now here on the inside, what I want to do, I will want to add a curve that comes roughly up to this point here. Give it some roundness. And once this thing is settled, then we can actually jump into the fun bit of this. So that can follow that line and then do the jump. I'll just keep it simple for the sake of this exercise. And this normally would end up being somewhere in the middle of that seed. So we can start coming up with some rough lines for the rough volume of this here. Also get the curvature evaluation on these 2 curves. The idea was to get it looking more like that. Actually, one easy way to do that is to take this curve, we copy paste it, let's pivot all the way top there, and then we rotate it a little bit till it hits that point, and we've got a very similar situation between the 2 curves. So that's our major building block, which will help us with the design. Another, let's say, boring thing, but you have to do this, is actually getting this in, getting actually the bolt pattern in. So we have a bolt pattern here of 5 bolts on a circle with a diameter of 128 millimeters. So let's do that. We bring in a circle in the side view. I snap it to that thing there. I might be actually wrong, but let's see, a center bore of a diameter of 75. at the radius there, 75 divided by 2, that's 37.5. That's more like it. And then this one, if it's 128, it's actually 60 for the radius. Now that looks more like the proper scale that we're looking for. Okay, and then the bolts, we'll make some holes for them. You can find sections actually online, and that's what we will do. I'll bring that up, and once I'm done with the rough design, I'll start cutting those out. But let's say the lug nut is an M14 times 2. So I found this. I'll take this picture and I'll save it. So I've brought in the canvas. I've got it to the proper size because that will be important for these angles and some of these things. So it's going to be easy to build the seat for this in the rim. And I'm almost done with the boring side of these things. So bear with me for a few more minutes, and once I'm done with that, we can jump into actually modeling this thing out. What I've done, I've adjusted this here a little bit, so I'm in compliance with those numbers, just for the sake of precision. Now, let's hide this away. I've used that as the center of that rotation, so that will move there. Move the pivot down there. And the first fun thing is actually getting these surfaces in. So I'll do revolve locally, and I'll play with the segments here. Should adjust just fine. So local pivot. If it doesn't want to do it, I'll do this. I'll make myself a vector here, and I know it's going to work 100%. So pick that vector to 5 segments. Each segment will be 72 degrees, 360. Let's do 4 segments. That's it. So that's where our bolt will go. And once this is done, I want to have it in the correct place, but let's just say we can now move that curve Y direction. Approximate it like that. That's already a cool thing. Now the next thing that I want to have is the feeling of that there. That looks like it's sitting on a revolved surface. It's got a nice constant, it's not a constant depth, but it's something to play with. So let's go ahead and define the plane. Let's see the surface on which that hole will sit. So for that, I will take this curve here, copy paste it, move it in by, let's say, the Y direction. I'll do, let's say, 7 millimeters. That's it. And also move the pivot here and rotate it ever so slightly so it gets deeper towards the center. That will allow us to have that effect there that we've got. So that looks thicker towards the end of it, but here it's actually a little bit deeper. So we'll have a nice twisting surface there. Okay. So that's that. All good. Now we can take this object here, move its pivot onto that center there, and let's duplicate this one. So we'll duplicate the object. We'll do 4 of these, so I can show you how we will proceed, and then we will be rotating on the y-axis by 72 degrees. And let's make some copies of it. And that's it. So that's our bolt pattern. And you notice that I've messed it up here because I left the -1 size there. So let's jump in this. We go into the attributes and we will scale it on the Y direction -1. Or we will do it just from the very beginning correctly. So again, we'll go into edit, duplicate object. We'll keep the scaling as 1, 72, 4 pieces, and that's that. That helps us see this. And we will need this when we're done with the main volume of the one spoke. We will do the same thing, but 7 times around the circle. And once that's done, it will intersect with the rest of the volume, and that's going to be actually the finishing touch on this rim. So in the meantime, I will be taking this object, this one. Let's put a radius there. I'll just do a freeform blend between these two, and that's it. It's just faster, basically, for me. Okay. Let's group this. Now, this. is going to be done the same way. So I'll go into surfaces, revolve, using the vector that disappeared. Something I'm not really keen on, but let's make a new one. It's going to be one along there, so that way. Cool. Let's rotate this. Let's revolve it. Around this. And you see slowly but surely this is taking shape. Now, we're gonna do it really interesting because we need 7 spokes. So we'll do per segment 360 degrees. No, 360. And I want 7 segments. Perfect. Now what I want to have is that this rim will have 1 spoke here. I'm going to build 1/2 of it correctly so it checks up with all the rest, and then we will rotate this. So the fun times will begin soon. But you see, these are simple tools that allow us to work really fast and get things done nicely and precisely. It's actually more of the prep work that we went through of getting the correct flange there and the correct circle here. That's the one driving, let's say, the extremely long times, the lead time for this thing. But once we're there, we're all good.